bases, and I explained you the meaning of conjugate acids and conjugate bases. So here I'm going to give you some examples. To have a review of the meaning of the conjugate acids and conjugate bases. Like for example, if I say NH3 is a base, then according to Bronsted-Lowry definition, a base, what is a base? A base can accept a proton, right? Yes, very good, Azuni. So if I say this is the base, what is the conjugate acid? What is the conjugate acid of this base? So you're going to add H plus mathematically. Means hydrogen with 1 plus charge. Right now there is no charge. So when you add hydrogen with 1 plus, it becomes ammonium. Azuni, yes, plus 1. Afan, you're getting it? This is the conjugate acid of this base. If I give you NH2 minus, and if I say this is the base, what is the conjugate acid? What is the conjugate acid here? Mathematically add H plus. Add H plus. The way we have done here, mathematically do it. When you add one hydrogen, then these two hydrogens will become 3 hydrogen. This minus, this plus will become 0. So write on this that if there is an acid and you want to make its conjugate base, CB means conjugate base, subtract H plus. If there is a base and you want to make its conjugate acid, add H plus. Please write on this. Now try to answer my question. Question is this. OH minus is the base. What is this conjugate acid? You know, base is converted to conjugate acid. Yes, what's the answer here? Yes, Ashlisha, very good. Afan, you're getting it? Use this definition. I'm saying it's a base. So add H plus. So when you add H plus in OH minus, it will become water. If I give you water as the base, what is this conjugate acid? Water is the base. Now again add H plus. Add H plus, Azuni. Add H plus. Mathematically add with the charge and the atom. Yes, H3O plus. Aslisha, plus. Ariba, start answering these questions. If I say H2O is an acid, what is its conjugate base? If H2O is an acid, OH minus. You are going to remove H plus. Remove H plus. You're understanding this, children? How to write conjugate acids and bases? We practiced this in the last class also. Okay. One last question. HB, HA, let's say HA is an acid. What is its conjugate base? What is the conjugate base of this HA? A minus, perfect. Now this HA is undergoing dissociation to give H plus and A minus. And we are saying it's a strong acid. If it is a strong acid, then the equilibrium or the reaction is totally on this side, on the product side. Check this picture. This is the initial picture before the dissociation. Let's say this is your HA, right? This is the initial picture. And the final picture is this. Do you have any undissociated HA here? Do you have anything like this over here? Check. Afan, do we have anything? No. What does it mean? That it is completely dissociated. Completely. Can you count these molecules? Count the molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 initially. This is initial. In this initial, do we have any H plus? No. 0. A minus 0. But finally, this is final. How much HA? 0. How much H plus? 10. How much A minus? 10. So this is called as 100% dissociation. Dissociation. In this case, the reaction is totally on the side of the product. 100% dissociation, strong acid. If I ask you to write down the equilibrium constant, let's say there is an equilibrium, because every system is an equilibrium, whether it is strong or weak. But if I say, what's the equilibrium expression for this strong acid? Which I'm going to call it as Ka. A means acid. It is acid dissociation constant. Can you write down the expression, children? Expression for Ka. It is same as equilibrium constant expression. Same. Means concentration of H plus, this one, the products, concentration of the products divided by concentration of HA. Yes, this is the expression. Lisa, she's trying to give me the value. But Lisa, when you put in the denominator 0, put 0 in the denominator. This is the expression. So 10 times 0. What happens to this Ka value? Very large or very small? The Ka value will be very large or very small? It will be very large. So remember this. For strong acids, Ka is very large. Right? This is the complete story of this picture. This one. You can see that it's 100% dissociated. The amount of HA, the amount of H plus and A minus, they all are equal. Now let's have a look at this picture. This one. And now again, this is initial. This first circle is initial. Initial. This is initial. Initial means before dissociation. And this is final. And this is final, right? Now in this case, HB is undergoing dissociation. Look at the final picture. Do we have undissociated? Yeah, it is not 100% dissociated. You can see that. Yes, Azuni. It is not 100% dissociated because you have HP here, undissociated, right? So I'm going to write down the equation first of the dissociation. Can you tell me initially here in this picture how many HP? I think it should be 10 only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So this is the reaction. Initially, they are 10. How many H plus in the initial picture? 0, 0. Now, final picture. How many H plus? And how many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 are still there, undissociated. And how many H plus? 1. B minus 1. What is Ka expression? Yeah, all of you please write down the Ka expression for this equation. Expression, not the value. Expression, concentration of H plus times, very good, divided by HB. That is your Ka expression, right? And in this case, if you plug in the values at the equilibrium, this is equilibrium now, because here your H plus and B minus are very less, HB is more. So here you need a rise table. It's not 100% dissociated. It's a weak acid. It's not 100% dissociated. Weak acid. Now here this is 1 times 1 divided by 9. Right? Is this value of Ka greater than 1 or less than 1? It's less than 1. If it is less than 1, then what is more favored, the products or reactants? Here the reactant is favored. Yes, Ashlisha, very good, reactant. And in the previous example, when it was a strong acid, in this case, products are favored. Products are favored. Is it okay? So can I say that we can compare Ka values to compare the strength of the acid? Compare Ka values to compare the strength of the acid. Compare the strength of the acid. So here I'm going to show you one question based on it. Strength of the acid. Are you clear about this line? You can see that when the acid is strong acid, we said Ka is very large. Please follow my pen. Strong acid, Ka is very large. Weak acid, Ka is very small, right? So it means I can compare the Ka values to know which one is strong and which one is. Okay. Now, Afan is asking that what's the formula for to solve Ka? This is the formula. This one. Or this one. It is the same expression as equilibrium constant. You remember A plus B in equilibrium? Let's say A plus B is in equilibrium with C and D. So what's the K expression? Concentration of C times concentration of D over concentration of A times concentration of B. This K is also the same thing, but now because it is for acid, so we call it as Ka. Products over reactant, concentrations in molarity. Concentration of the products over concentration of the reactant. It is always in terms of molarity. You're going to do many questions in which you'll be using this expression. Afan, so we are going to use this formula to calculate Ka or to calculate H plus. Okay, now we are on this part, this one. Please pay attention to this last thing which I have written here, over here, this one. And I'm going to ask a question. There is an acid, HF. Okay, I hope you have done all these things. Based on this concept, I'm taking you on the next slide to discuss the strength of the acids based on their Ka values. Strength of the acids based on the Ka values, and then we'll discuss the strength of the conjugate also. Okay. These are acids, all of them? Yes or no? And how can you identify them as acids? There are two ways of identifying these as acids. One, they all are starting with, yes, starting with hydrogen, except this one, but this is also an acid. But rest all, see, it's not a fixed rule. Second way, that their Ka values are given. Ka values are given. So what is Ka? What's the full form of Ka, children? It's an equilibrium constant, but this one is for acid. So it is called as acid, yes, Azuni, acid dissociation constant. And what is Kb? Is the base dissociation constant, right? They all are equilibrium constants. You are going to use the same concept on them, what we have done earlier, like Lee-Chatelier principle, calculation of K value. If this is given, that is given, what is Ka? If K is given, what is H plus? Everything, whatever we have done in unit 7 is applicable here. And then if it is Kw, what is it called as? W means water. Water dissociation constant. Water dissociation. They all are equilibrium constant, but for a particular compound. If it is acid, you call it as Ke. If it is base, you call it as Kb. If it is water, you call it as Kw. You have already done this Ksp. You remember in unit 7, last part, we were doing solubility product. Saturated solution is in equilibrium, then you're calculating Ksp. This we have already done, right? So here, these are the Ka values given to us. Okay, look at the Ka values, all the Ka values. Are they strong acids or weak acids? All of them. Are they strong or weak? I already explained you, if Ka is greater than 1 means large value. If Ka is less than 1 means small value. So small value means weak. So what do you think, Afan? These are strong acids or weak acids? Ariba, you're answering? Ariba. Mhm. So all these are weak acids. But I can compare them. Let's say if I say compare HF. You can see HF here somewhere. HF, this one. Compare this with acetic acid. Mhm. Which one is stronger? These questions are there in free response. They'll give you Ka values and they will ask you which one is stronger. They will give you 2, 3 Ka's values and they will ask you to arrange them in increasing order of strength or decreasing order of strength, right? So Ka values are so important. They can tell you which one is stronger, right? Okay, compare this one with this one. Which one is stronger? Yes, HSO4 minus is stronger. Now, before I start teaching you anything else, let's do one thing. Can you give me the conjugate base of all of them? Very fast. Conjugate base means your acid will be converted into its conjugate base if you remove H plus. Remove H plus mathematically. Remove one hydrogen and remove one plus charge. So what is the conjugate base of this? Let's write here conjugate bases. What is the conjugate base of this? Who is this? Azuni, you are not taking care of the charges. And Aslesha is right. SO4, 2 minus. Conjugate base of this. Remove hydrogen with a plus charge. If it is neutral, you are left with one negative. This was already negative. So when you removed H plus, it became 2 minus. Yes, remove hydrogen, Afan. And Azuni, remove hydrogen. So what is it? ClO2 minus. Mathematically remove hydrogen with 1 plus charge, right? This one. And you're going to remove this first hydrogen. What's the conjugate base? Mhm. Afan, be the first one to answer. C2H2 ClO2 and then 1 minus. What's the conjugate base? F minus. What's the conjugate base? NO2 minus. What's the conjugate base? C2H3O2 minus. And here, be careful. This question we did earlier also. This one. So you're removing hydrogen from one of the water. So out of 6 water, 5 waters will remain like this only. But one water will become OH minus. And that OH minus and this 3 plus, this is OH minus, right? And this is 3 plus. It will become 2 plus now. So there are 6 water. I removed H plus from one of the water. So I'm writing 5 water as such. They are not undergoing any change. One water is OH minus. So this is 3 plus and then 1 minus. It will become 2 plus. Is it clear to all of you? Now, what's the conjugate base for this? This one. Conjugate base. Yes, remove hydrogen. You can write it OCl minus or you can write it ClO minus. If you see, all these are polyatomic ions. This is hypochlorite. What's the conjugate base of this one? This one? Cn minus. Very good. Now be careful. Answer this. What's the conjugate base of ammonium? Conjugate base of ammonium. Perfect, Lisa. Perfect, Azuni. What's the conjugate base of this? Remove H plus. Yes, very good. It's very important to know the conjugate acids and conjugate base. The way we have done conjugate bases, exactly in the same way we can work with conjugate. The way we decided conjugate bases, exactly in the same way we decide conjugate acids. In that case, base, you just add mathematically. Mathematically means add one hydrogen with a plus charge. So you have to see the mathematically the charge also. Like if this base has no charge, like this, let's say this is B, no charge, it will become, yes, it will become HB plus. If I give you a base with a negative charge, to add H plus, mathematically, it will become HB. Very good, Azuni. Perfect. Very good. Children, are you getting this? It's very important. Okay, back to our understanding of the strength of the acids and bases strength. You can see that some of the very important acids are missing here. What are those acids? I gave you the list of strong acids and strong bases earlier. Yes, Aslesha is saying HCl is missing. What else? What else is missing? Okay, I'm sharing the table for acids and bases. Let's see if I can get it. Uh, I think I gave you earlier also. No? Yeah, it's here. Check this. Download this file, children. Yeah, H2S is missing. Yeah. HNO3 is missing. HI is missing. Good. Now download this table. Now let me talk about first non-oxo acids. Non-oxo means the one without oxygen. So in non-oxo acids, only this you can memorize. It's important, children. It's there in the table. This I discussed earlier also with you when we were doing strong electrolytes and weak electrolytes in unit 4. In non-oxo acids without oxygen, only HI, HBr, HCl are strong acids. You can see that they all are missing here. Are strong acids. Nothing else. All rest are weak. All rest are weak. Please write down. I'm going to trouble you for this. I'll give you an acid and I'll ask you, is it strong or weak? So you're going to use these rules. Only these are three are strong. Now, Eslisha was saying H2S. What do you think H2S? Strong or weak? Strong or weak? H2S is weak. Though it's not there, but it can be there, right? And the strong acid, what is their Ka values? Greater than 1 or less than 1 for strong acids? Ka value greater than 1. That's why it's missing. All values are here less than 1. It's 100% dissociated, all of them, right? And in case of weak acids, Ka value will be less than 1. And it's not 100% dissociated, right? Okay. Now, this is non-oxo acids. In case of oxo acids, oxo acids. I'm writing some rules here. We don't have very simple rule like this. This is simple. You need to memorize these three and rest all are weak. Things are over. But here, you need to memorize six important acids. They are strong. HNO3, which is called as nitric acid. H2SO4, sulfuric acid. HClO4, perchloric acid. HClO3, chloric acid. Oh, these are four only, sorry. 4 plus 3, I was combining these two. So these are the four acids, four oxo acids. Can you memorize them? Which are strong. I'm not writing that rest all are weak. No, no, it's not like that. But these are the one which we need to know for AP chemistry that they are strong. And how to identify weak acids here? All carbon containing, if you see carbon, if you see phosphorus, all carbon containing and phosphorus containing acids are weak. And carbon, you know, is the part of our body. We have so many acids in our body which are carbon containing, like carbonic acid, H2CO3, acetic acid. You see, all these carbon containing, they are weak. So if there any carbon containing acid, any, you need not to worry. You can simply classify it as a weak acid. Please remember that. Even any acid containing phosphorus, you know, our DNA, RNA, they have phosphoester linkages. Phosphorus is there in our body. Phosphoric acid is there in our body. Body cannot take very strong acids. So phosphoric acid is weak. So carbon containing, phosphorus containing acids are weak. And in the nomenclature, which you did with me in unit 1, in depth, all the nomenclatures were done. If your acid is ending with us, then it's a weak acid. These are the three things which you have to memorize for oxo acids. You can memorize it. It will help you. Please memorize it before the next class. Your next class is on Saturday. Some children are saying that cannot attend, then I request them to watch the video. Only for one Saturday, this Saturday, right? So watch the video if you are unable to attend it before Sunday class. This Saturday, Sunday, there is class. Saturday, if you cannot attend, then watch the video. You can bring your difficulties. You can discuss the difficulties with me. Okay. The aim is to finish everything by 25th Feb. Then start the review classes by 10th March. Right? Okay. So, Afan, you have memorized this list of weak acids and strong acids and oxo acids, non-oxo acids. Exactly in the same way, you're going to do a strong base. Strong base. There is a list of strong bases. And this is also very simple. Only hydroxides, you know, hydroxides are bases. Only hydroxides of first group metals. First group metals. You know first group metals from the periodic table? Sodium, potassium, lithium, cesium, rubidium. And two from second group. Calcium 2 plus and barium 2 plus. Only these are strong bases. Only. See only here are strong bases. Rest all are weak. Rest all are weak bases. Can you memorize this line? Okay, let's see. If I give you MgOH twice, answer it. Is it strong or weak? It's weak. Now it's a base. So we'll talk about Kb. Is Kb greater than 1 or less than 1 for this? Kb less than 1. Very good. If I give you ammonia, if I say ammonia is a base, is it strong or weak? Mhm. Yes, it's weak because it's not there in this list, which I've said only. Ammonia is not there. Nothing else is there. If I give you anything other than these, it's weak. Kb is less than 1. But if I give you BaOH twice, is it strong or weak? Strong. Kb greater than 1. And remember, when we are working with strong gases, strong bases, there is no equilibrium. It's totally on the product side. Totally. So remember this line. So whenever there is a strong acid, I will put only one arrow. Only one arrow. Means everything is on the product side for strong acid or strong bases. There is no equilibrium constant value. There is no equilibrium. Right? But if I work with weak acid or weak base, then I have to put an equilibrium there. Then I have to make the Rice tables, equilibrium, all the concepts of equilibrium can be used now. But in case of strong acid and strong base, I will work all the questions based on initial and final. Children, I'm giving you a base on the questions which we are going to discuss in coming Saturday, Sunday classes. Saturday, Sunday class will be totally questions, calculation of the pH. Today we are making the base of that. We are clear about all these things? Okay, now I'm going to erase this and now I'm going to ask something else which is easy to understand. You know that you said HCl is not here. Is HCl a strong acid or weak acid? HCl, strong or weak? Afan, strong, very good. If it is strong, then it means it is fully dissociated as H plus aqueous. What is the meaning of H plus aqueous? Like water. H plus aqueous. Aqueous means in water. So H plus aqueous means, anyone? Means H3O plus. Remember definition by Arrhenius, Bronsted. Bronsted was up to H plus, but Arrhenius was saying if you get H3O plus in water, it's an acid. So rather than writing H3O plus for acids, we can write H plus aqueous. But the meaning is this, right? Plus Cl minus aqueous. Reaction is totally in this direction. Answer my questions. So I'm asking question, children. The first question is, what is the conjugate base of this acid? This is acid. What is the conjugate base? Cl minus. This is the conjugate base. Okay, good. Now, is this conjugate base this conjugate base, is it accepting this H plus and going back? Is this Cl minus willing to accept this H plus? No. So is this conjugate base a strong base or weak base? Is it strong or weak? Yes, very good, children. Now write down this. If you take a strong acid, then its conjugate base will be weak. Conjugate base has less tendency to add H plus then. Less tendency means it's weak. So a strong acid will give you a weak conjugate base. Now let's take HF. HF is weak acid. Weak. Is going to dissociate only partially like this, right? So here you can see that there is HF and there is F minus. If this is the acid, weak acid, what is its conjugate base here? This is conjugate base. Is this conjugate base weak or strong? It's going back also, right? See equilibrium here? There is no equilibrium here. There is. Is it strong or weak? This F minus. Strong. Strong. But here strong doesn't mean 100% dissociated. You can see that it's still not 100% dissociated. But yes, you can say that F minus is a stronger conjugate base than Cl minus. This is weak conjugate base. I can compare the bases, right? Are we understanding this? So let's make it like a statement. The statement goes like this. If there is a strong acid, SA means strong acid, with high Ka value, then you get a weak conjugate base. One statement is this. Sorry. Second is, if there is a weak acid, then it will give you strong conjugate base. Weak acid means low Ka value. Low Ka value, magnitude. Magnitude of the equilibrium constant can tell you what is dominating the products or reactants. The way I've written this, the same concept is valid for bases. Ready to write for the bases? If there is a strong base, the conjugate acid will be strong or weak? Complete it. If there is a weak base, yes, please complete this. A strong base will give you conjugate acid strong or weak? Yes, weak. A weak base will give you strong. Same concept, same explanation, same understanding. So can you write down these things? Because after this, I'm going to ask questions. Write on these two boxes. Ariba, keep interacting with me, okay? Who else is not interacting? Lisa, ready for questions based on this concept? Okay. I'm highlighting here two acids. One is HOCl, this one. Other is ammonium. Which one is going to give me stronger conjugate base? Look at their Ka values. Which one is going to give me stronger conjugate base? Yes. And what is the conjugate base of ammonium? NH3. NH3 is stronger base than OCl minus. So you're comparing the Ka values, and from there you are working on the conjugate bases, right? Okay. Now what happens to these conjugate bases? Now I'm teaching you one very important concept which will be needed in rest unit 8. When you said OCl minus is the conjugate base, so you're working with HOCl, HOCl in water undergoing dissociation to give you H plus aqueous and OCl minus aqueous. That's the equation for the acid. If somebody asks you to write on the equation for the base, the conjugate base, OCl minus, this, what will be the equation? We are learning how to write on the equations, which is very important for calculation of pH, for titrations, acid-base titrations. This is the topic in unit 4, I think. I said that I'm going to discuss more in detail in unit 8. So that topic, few more topics which we left just because of the pH and dissolution. Now this OCl minus is the base here. It's not an acid, it's a base. How to write down the equation? You are going to put this into water and is going to accept H plus from water and it will become HOCl. This is how we are going to write down the equations for the conjugates with water. And what happens to water? Water will become OH minus. That's why it is a base. It's giving you OH minus in water. Right? So here OCl minus is the base. This is the base. And what is water here, children? What is water? Acid. What is HOCl? Conjugate acid. What is OH minus? Conjugate base. If I say ammonia is the base, you see this conjugate base, ammonia base. Can you complete the equation with water? So generally with the bases, we need water always to show the dissociation. With acid, you see this is the acid. I'm not showing water because water is the part here, H plus water. For acid, we may not need that water in the equation, that we can simply do as AQ. But for the base, water is compulsory because how you're going to show OH minus then? Yes, ammonium plus aqueous and OH minus aqueous. Now I'm telling you another important word. This base, this OCl minus is behaving like a base in water. Children, water can behave like an acid. Water can behave like a base. Like if I give you this HSO4 minus, and if you put HSO4 minus in water, is going to get converted into SO4 2 minus and H3O plus. So what is HSO4 minus? See the change? Is acid. What is water? Is base, isn't it? So in reactions, water can behave, in fact, everyone, but now we are working with water. So water can behave like an acid. It can behave like a base. It depends on the partner. If the partner is stronger base, then it will start behaving like an acid. If the partner is stronger base, this is partner. Partner means what you added in water. If the partner is stronger base, then water will behave like an acid. And if the partner is stronger acid, then is going to behave like a base. Like here, water is behaving like an acid. See? So it means OCl minus is stronger base than water. Stronger base than water. You know that some people, they dominate on one person, but they cannot dominate on other person. You will say, oh, you are so dominating. But that person will say, no, I'm not dominating. I'm very quiet person with in front of my parents. But the same person is very dominating, very bully in front of his or her friends. So it depends on the strength, whoever is more stronger. If water is stronger base, the other is forced to behave like an acid. If water is stronger acid, the other is forced to behave like a base. Okay, same here. OCl minus is stronger base than water, so water is behaving like an acid. Here, ammonia, ammonia is stronger base than water. You're understanding this? So the conjugates, we are going to decide about the conjugates, whether the conjugates are stronger than water or weaker than water. Ready to write down one more breaks? Yes. See here what ammonia is doing. Ammonia is the conjugate base of ammonium. Ammonium is very weak acid. Ammonium. Ammonium is weak acid. So its conjugate base is stronger. That is ammonia. Stronger than water. That's how you know. It's going to behave like a base in water. That's what I was about to tell you, Afan. In fact, you started thinking ahead of me. That's what I'm about to tell you, all of you. Please write on this what I'm going to say. It's very much related to what he's asking. If you have a strong acid, that strong acid will give you weak conjugate base. This weak conjugate base is weaker than water, weaker than water. Nothing will happen. No change, no reaction, no change. For example, HCl, the conjugate base is Cl minus. Nothing will happen to Cl minus in water. It will remain as such. HBr, Br minus. The water will not react with them because they are very weak. They are not reactive because they are the conjugates of strong NO3 minus, like this. So no change. No change with water means generally the reactions with water, we call them as hydrolysis. Hydrolysis means they are not getting hydrolyzed by water. No hydrolysis, right? Hydrolysis means reaction with water. Hydro means water. No hydrolysis. Nothing will happen with water. But This is the case with strong acid as well as with strong base. Both of them are going to behave exactly in the same manner. Strong acid will give you weak conjugate base. Strong base will give you weak conjugate acid. So they will not interact with water at all. And you know how to identify your strong acid and strong bases. So you know this complete chemistry then. That is the reason I said memorize your strong acids and strong bases. But if it is a weak acid or a weak base, then the conjugates will be strong. Strong conjugate acid, strong conjugate base, stronger than water. Both of them are stronger than water. Stronger than water means when you put them into water, they will react. They will get hydrolyzed. Like if I give you a weak acid, HCN, it's a weak acid. You see here, all carbon containing acids are weak. Now, what is this conjugate? Yes, children, what's the conjugate? Conjugate base of this acid? Mm-hmm. Very good, Aditi. Cn minus. But now this is a strong conjugate base. It's stronger base than water. So when it goes into water, it will force this water to behave like an acid. And water is going to give H plus ions to this Cn minus to give you HCN plus OH minus. Please learn all these equations, how to write them. This is called as hydrolysis of Cn minus. Why Cn minus is reacting with water? Because it's stronger than water, stronger base than water. So it will force water to give H plus. See, it's gaining H plus, right? Check here. It's taking H plus, so it's a base. And water is donating H plus, so it's an acid. Is it okay? And if I give you a weak base, like for example, CH3NH2, it's a weak base. Weak base. You already know how to identify weak bases. I've given you the rule. So if I give you this compound, if I say it's a weak base or strong base, now you memorize the rule that only first group hydroxides, including 2 from second group, barium 2 plus, calcium 2 plus, rest all are weak. It's weak. Weak base. This weak base, when you convert that into its conjugate acid, that conjugate acid is strong. Stronger than, please do not think that it's 100% dissociated, it's very, very strong. No, no, no. It's just stronger than water. It's stronger than water. Means when it goes into water, it will react with water. It will ask water to behave like a base. It will force water to behave like a base. And this conjugate acid will donate a proton to water like this. This is the equation for a weak conjugate acid in water. You can see that you're getting hydronium. So it means it's an acid. So how these conjugates, how these weak acids and weak bases and their conjugates are going to behave in water, that's a very important concept. So there are questions based on calculation of pH and even on titration graphs. We have to understand these things again. If you have any question, please ask. Any question here? It's a big thing. Can we do another example? Okay, why not? Okay, this time it's not from my side. Like I will put a question, you are going to answer it. You're going to answer very carefully. You have the list of your strong acids and strong bases. I told you to memorize them. You can memorize within seconds. HNO3. Is it a strong acid or weak acid? Is conjugate base. What is the conjugate base? It's a strong acid. Conjugate base is strong or weak? Is weak. This is weak. If it is weak, is it going to react with water? This is weak conjugate base. Is it going to behave like a base in water? No. So with water, you will say no reaction, right? No hydrolysis. Clear, Afan? Now, HNO2. Is it a strong acid, weak acid? You remember I said all the acids ending with us. This is nitrous. This is nitric. If you do error here in identification of your strong and weak, then everything will fall. HNO2 is nitrous. Nitrous. So please practice nomenclature of acids and bases. So HNO2, what is it? Weak or strong? It's weak acid. What is this conjugate? Conjugate is a strong conjugate base or weak conjugate base? Strong conjugate base. This strong conjugate base will react with water. It's stronger than water. Again, I'm repeating. When I say strong conjugate base during this unit, I will be saying it so many times. Please don't take it strong like NaOH, KOH. It's not 100% dissociated. When I say strong conjugate base means stronger than water. So water is going to behave. Yeah, it has a reaction. But how the water is going to behave now in the presence of this conjugate base, which is stronger than water? How the water is forced to behave? Yes, anyone? Yeah, it's going to behave like an acid. Now, this is the tough part, and this is the important part. Can you complete the equation? Complete the equation, please. You know who is the base, who is the acid. Base will take H plus, acid will donate H plus. Okay. Okay, Aditi, I think by mistake you have written something else. I can make out. It's a typo error. Yeah. Okay. Afan, you have to go step by step. If this is the base, it's going to take H plus. Add H plus. Then it is HNO2. You are adding H plus. This is minus. Minus plus 0. No charge. Afan. And from this, remove H plus. So it becomes OH minus. This is what I want you, all of you, to practice. This is what I have seen 90% children are unable to write. Most of them. Hardly smart children, 5% are good with this. But it's not tough. If you practice your acids and bases, if you know this is strong, this is weak, you can write the equation, right? Okay. So moving on, children now. This is the column which is based on the strength of the acids and their conjugates. So if Ka value is, if it is a strong acid, all these things I have already discussed. If it is a strong acid, Ka is large, greater than 1, then it means the equilibrium is totally on which side? On the side of the product, far to the right, dissociation, far to the right, which is called as ionization or dissociation or equilibrium constant. We are okay with these things? These are multiple choice questions. MCQs, right? And in this, the concentration of H plus and A minus and the concentration of, you remember I was showing you a graph. If this is the concentration of HA, we call it as initial. Initial means not here, T0. This thing you have done in kinetics with me. So if it is a strong acid, it's going to dissociate completely to give you same amount of H plus and same amount of A minus. So that's what they are writing, that H plus and HA are nearly same. If this is 2 molar initially, after dissociation, this is also 2 molar. So please remember that. Okay. And what else? The conjugate base is weaker than water. No reaction with water. This is what I was explaining you earlier. No reaction with water. Now, for the weak acid, Ka is smaller than 1. If this is the weak acid, Hb, then there is an equilibrium, H plus and B minus. Now, if this is Hb initially, so do you think H plus will be same as Hb? No, it will be smaller in amount. It's not going to be same. This is the dissociation of your weak acid, right? So H plus concentration, this one is much lesser than Hb, much lesser than Hb. The initial, this is B, let's say, right? And A minus, here in our case, I took BHB. This booklet is taking HA only. Then B minus is stronger base than water. If B minus is a stronger base than water, then this B minus is going to react with water like a base. Can you complete this equation? Can you complete this equation, children? Is stronger base than water. The base. Water is the acid. Write the products. Yes, base is going to take HB. Very good. And water will become OH minus. Afan, if you are struggling with it, do let me know, okay? We'll practice more. So the complete unit, whatever is left, is based on writing the equations, okay? So these things will be repeated again and again. If somebody is struggling, please be honest with me. You're learning here. You're not the master of chemistry. So you can do errors. That's not a problem, okay? We are trying to become master of chemistry, but yet we are not. So ask your questions. Don't hesitate. More you ask the question, more you like the class also. You will not be sleepy on the other end. Okay, so I'm introducing you with water again. Water, children, is very versatile. It is the life on the earth. There are so many things about water which you have already done with me. Okay. This equation, Afan is asking me to go back. Okay, good. Write, speak, discuss with me, put questions here. If you feel that your question is too lengthy to type, I give you permission to unmute and speak. Okay, children? If you feel that that question is too lengthy to type, so you can unmute yourself and you can talk to me. Questions are always welcome here. Okay, now let's talk about water again. Children, you have done water, is melting point. You know it? Is boiling point. Is density. And is specific heat capacity. Unit 6. So what's the melting point of water? If you don't know, make a list. Because this is the most important compound in chemistry. Though it's not very reactive, but it is the life of chemistry also. The melting point is 0 degrees Celsius. It's also called as freezing point. The boiling point is 100 degrees Celsius. This is our best friend, water, in life and in chemistry. And the density is, what is density? Anyone? 1.0 grams per ml. You did this also with me in the unit 6 when we were calculating the mass of the solution. And even in unit 4 where we were learning concentrations. And anyone with a specific heat capacity knowledge, this is one of the most important thing. Higher specific heat capacity. Yes, Ashleisha, very good. 4.184 joules per gram per degree Celsius. We spent so much time with it. And today you are going to learn another important constant for water, which is called as dissociation constant of water. And its value is 1.0 times 10 raised to power minus 14. New friend, this is a number which you will not forget now because you are going to do plenty of questions on it. 10 raised to power minus 14. Let me write it again more clearly. Kw, Kw means dissociation constant of water. Its value is 1.0 times 10 raised to power minus 14, and this value is at 25 degrees Celsius under normal conditions of temperature. Right? This is new friend. Now let's try to understand the meaning of Kw. Children, I was telling you that water can behave like a base and water can behave like an acid also. It depends who is the partner, right? If partner is a strong acid, it will become a base. If partner is a strong base, it will start behaving like an acid. It's not only with water, it's with everyone, every compound. A compound behaving like an acid in one case, but the same compound will behave like a base with somebody else. It depends who is the partner. It's very important to know that I decided HNO3 as an acid. I said it's a very strong acid. Very strong. It's an acid, very strong. We know that, right? But when I put this strong acid in another strong acid, H2SO4, children, H2SO4 is also called as king of acids. It is actually not the strongest. Strongest is HClO4. This is the one which is strongest. But H2SO4 is very strongly used everywhere. It is very high in demand and is stronger than this HNO3. If I put, question for all of you, please. Question for all of you. If I put HNO3 in H2SO4, and if I say that H2SO4 Ka value is greater than HNO3, how this HNO3 is going to behave now? Yes, please. How it is going to behave? As an acid or a base? H2SO4 is stronger acid than HNO3. It's going to behave like a base. Very good, Aslisha. And how this H2SO4 is going to behave? Like an acid. Can you complete the equation? Can you complete the equation? H2NO3 plus. Add H plus. Add H plus into the base. Remove H minus from the acid. H plus from the acid. Remove. And what else? Yes, Lisa, very good. HSO4 minus. Very good. See, that's what I'm trying to tell you, that if you are base and there is somebody else which is stronger base than you, then you will start behaving like an acid. Rather than taking a proton, you will give a proton because the other one is stronger. So whoever is stronger will dominate. Yes, yes, Azuni. If Ka value is greater, then it means it's a stronger acid. You remember we were discussing? So here, water can behave like an acid and base. Now let's see how water is behaving in its solution. It's not a strong acid. Water is not a strong acid, and water is not a strong base. Water is a weak acid and weak base because water is the part of our system. Your body is made up of water, so much water. It cannot be strong acid and strong base. You are drinking water every day, so definitely it cannot be strong acid and strong base. So when I take pure water, pure, nothing is added, nothing is there. Okay, pure water, nothing is added, right? Then water molecules, they can behave, not all of them, few, only few. They can behave like an acid and base. Now check here. I'm just giving them different color and you are going to identify them as like this H2O is converted into this H3O plus and this H2O is converted into OH minus. You can see this equation here. This is water. This is water. This is H3O plus. This is OH minus. You can see the red is oxygen, the whites are hydrogen, right? Okay. So what is this called as? This is called as autoionization of water. Auto means the water molecules are ionizing each other. One is behaving like an acid, the other one is behaving like a base. See here. What is this red water? What is this water? If it is getting converted into this, what is it? It's the base. Yes. And what is this water? This one is the acid. That's the equation which I have written. Autoionization of water. It's a very important concept going on, children. Everything is important. They can be in the form of multiple choice questions. What's the equation of autoionization of water? This is the equation. Now you already know that this water is liquid, pure liquid, liquid. But these are in the water aqueous, aqueous. If I ask you to write down K expression, equilibrium expression for this, what's the equilibrium expression, children? Mhm. Equilibrium expression, which I'm going to call it now Kw, the water dissociation constant, the water ionization constant. This is called as water dissociation constant. By the time I'm writing this, can you give me the expression for Kw? Can you compare your answer, Azuni, with Aditi's? Aslesha, you compare your answer with Aditi and with Lisa. Lisa, you are not placing concentration mark. Yes, Afan, Lisa, and Aditi are right. Okay. Azuni, can you tell me why are you wrong? Aslesha, you are wrong. Aditi, Azuni, you are wrong. Why? Oh, okay. You're asking me? You have done the equilibrium, right? Because it's liquid. Yes. And liquids are not the part of your equilibrium expression. Kw is called as ionization constant or equilibrium constant or water dissociation constant. Ionization constant of water. Kw. W means water. You cannot use it anywhere else. So they will ask you, okay, what's the expression of Kw? As I said, every line is important. Every expression is important. So what's the expression for Kw? It is the concentration of H3O plus times concentration of OH minus. Liquid water is not the part. Generally, they show it like this is a constant, right? There will be hardly any change in their concentration. So it's constant. Constant, constant, like some books are writing it like this. K, see here, they're writing like this. Concentration of H3O plus times concentration of OH minus divided by concentration of H2O squared. They're writing like this. Then they are saying this concentration of H2O squared is a constant. We know that why? Because it is much in amount, very large amount of H2O is there. It's the solvent, it's the pure liquid. That's why it's a constant. So what they are doing, they are taking this constant on this side. This you can see in the books. This constant is here now. They are combining water concentration constant with K value. They're combining it. This. And now they are calling this as Kw. You're getting the same expression. So I'm just telling you this because maybe in the book you can see this part. Then don't get confused. So Kw is this only. And we'll be working with this equation, not with this equation. Okay. So here I told you that water is constant. That's why I'm not taking it. So we'll work with this equation. Is the Kw expression clear to all of you? This Kw is the equilibrium constant. All equilibrium constants, they have values. And now this Kw value at 25 degrees Celsius is our new friend. The value is 1.0, any one of you, times 10 raised to power minus 14. And no units. Yes, Afan, very good. More you type, more you speak, the way you are watching a movie, just take that much interest. I know that you cannot take so much interest all the time, but when you start understanding, it's a beautiful thing we are learning. This tells you how the surroundings are behaving. Why we are learning science? Because from this, we are understanding our surroundings. And by understanding the surroundings, we are trying to protect ourselves. I request you to watch some these this what is it called, a Discovery Channel, the wildlife. When you watch these wildlife movies, you see that how animals are struggling for every night, every day. They are struggling for their life. They are struggling for their food. They can be killed. Next day morning, they may not be there in the world, but we are safe. So we have not achieved this thing just because we are blessed by the God. One day God came and He gave us so many things and we are now safe. No, people worked very hard. They try to understand the nature of the surroundings. They converted that understanding into science. They imparted this knowledge of science to their children. The way I'm giving you information. My aim is not AP chemistry. My aim is to make you understand chemistry so that you can understand why the things are behaving like this around you. You try to relate them, right? Because this can protect you from the surroundings. You can predict what can happen in the surroundings. Now I should move from here. I should go like this. Okay? It's very important to learn science. So this is the Kw value of the water. Water is a major component of everything. Okay. Now, this is autoionization because we are left with few minutes. Oh, Azuni is saying from where you picked up this value 25 degrees Celsius. Azuni, if you remember from chemical equilibrium constant, value of K depends on temperature. You remember that I told you in the Le Chatelier principle? Only temperature can change K value, only temperature. If you look at the question which we did together, every time with the K value, temperature is mentioned there. This K is measured at this temperature. Same here. When we are taking water and calculating the Kw, if the temperature of that water is 25, then Kw is this. If you change temperature, if you make it 30, 40 or less than 25, Kw changes. So this is the temperature at which Kw has this value. This is the temperature at which Kw is measured. Is it okay, Azuni? Last question, children. Before you leave the class, do this question. The way we have done autoionization of water, there can be a question like this. NH3 liquid, another NH3 liquid undergoing autoionization. One is behaving like an acid, other one is behaving like a base. Can you predict the products? Let's take this acid as blue. It's behaving like an acid. So it will get converted into its conjugate base. What is it? Very fast. Very good, Azuni. You're listening very carefully. NH2 minus. And the conjugate acid is NH4 plus. Was the K ammonia expression? Now ammonia, right? Autoionization of ammonia. What is it? Yes. What is it? K ammonia is concentration of NH2 minus times concentration of ammonium plus. And it also has a fixed value. We need not to memorize. I told you to just work with Kw of water. We are not using this in any question, but yes, this example I have given you to make you understand the meaning of autoionization. So they may ask you, do the autoionization of this or that. Okay, children, now you have a class on Saturday in your morning. Those who cannot join, I will ensure that I upload the video at the right time. So you have to watch the video and then join the next class, which is on Sunday. These are extra classes going on just to wind up the syllabus. So I'll see you then in the next class on Saturday. If you have any questions, you can stay back.